Hi, this is Pavel from MinIO. In this course, you will build a RAG application using MinIO object storage. First, we will start with the definition what RAG is, and obviously it will need more than just description in 3 words, retrieval augmented generation. Then I will show you the architecture of our RAG application and its components and its workflow, and we will discuss how to use MinIO object storage to store documents, their metadata, and vector database. And then I will show you the actual application. You will see how it works. It's pretty simple. And then you will be able to reproduce it yourself using the description in our document, in our lab instructions. First, let's start with RAG. RAG stands for Retrieval Augmented Generation. And obviously, we need more explanation than just these 3 words. Imagine you want to use large language model, LLM, to answer some questions. And of course, LLM can answer questions on topics which were included in its training set. But sometimes we want to ask questions about some recent events, or maybe some area which is quite niche. And we can imagine that those documents were not included in the training set of that LLM. And to do that, we have to provide LLM with some context related to our questions. To provide this context, we want to get some documents and find some pieces which are relevant to our question. To do that, first we have to prepare the documents. If we have a corpus of documents, we want to split them into pieces, and then each piece will be maybe 1 or 2 paragraphs, and each piece will be converted into a vector, into its numeric form, and uploaded to a vector database. Why we do that? We want to be able to calculate the semantic distance between our question and our fragments of the documents. And to do that, we also convert the question into a vector, and our vector database will be able to find the closest pieces of our documents closest to the question. So that's the purpose of this RAG application, to find pieces of our documents which were not included in the training dataset to provide proper context for the LLM to answer our question. So that's the idea of RAG applications. Now let's take a look at the architecture of our application. As you can see, we have object storage using MinIO, and we have 2 buckets in this object storage, and we use the first bucket to store our documents. Imagine we have a user, and this user wants to add a bunch of documents to this bucket to provide some context. In MinIO, we have a thing called events. And each time you upload a document, you can generate an event, and that event will trigger some operations using so-called webhook server. That webhook server will split the document, which we just uploaded, into chunks. We usually call it chunking. And then it will vectorize those chunks using the embedding LLM. And then those vectors, together with the chunks, together with the fragments of our documents, will be uploaded to the vector database. And this vector database is also stored in the object storage. In our case, we use LanceDB, and you will see this in the example. This is the first step of RAG application. The second step is the actual question answering. Imagine we have a user, probably a different user, who wants to ask a question. The user asks a question, and then the question is vectorized as well using the same embedding LLM. And that's important. We have to use the same embedding LLM which was used to vectorize our documents. Then, using the vector database, we calculate the semantic distance between the question and the document fragments. and we find maybe 3 or 5 of the closest fragments of those documents, and we collect them together and we create a prompt which includes both the question and several chunks of the documents as a context. And then we send this prompt altogether to the question answering LLM. And please take a note that it's a different LLM. It's not the same as we used for embedding. And this LLM is specifically designed to answer questions. And then when we provide enough context from those chunks in our prompt, then the LLM now can answer the question. And then the answer goes back to the user. So this is how it works. This is the workflow. Now let's take a look at the components. The whole demo will be running locally on my laptop. First component is the MinIO server. So it's running locally and it uses the local disk to store the vector database and store the documents. The second component is the server, which provides this webhook functionality. And this server can split the documents, can vectorize them using the embedding LLM, and then send them to the vector database. And the vector database is so-called embedded database. In this case, we use LansDB. Another component is the Ollama server, which runs again locally on my laptop, and it serves 2 models. One model is called Nomic, which is used to vectorize our questions in our documents as an embedding LLM. And the other model is called Phi3, which we use to answer questions. And in the code, you will see that we tested several other models, and you can test them as well and find which one gives you the best answer. And finally, we use a Gradio framework to provide a simple UI for this application. You will see that it has 3 areas. One area is to ask questions. The other area is to see the answers from the LLM. And the third area provides you with context. It shows you the exact fragments of your documents which were used as context for the LLM to answer your question. So that's the overview. Now let's take a look at the demo.